Hello, Alex. Good. It's been 3 weeks. Yeah, 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 yeah. Can we just see in the chat that everybody can hear us okay? No. Yeah, so I think I got.
Let's
Uh,
check. We'll do a
how
test.
about now?
Awesome. We got one yes.
Yes. Great.
Excellent. Cool. Thank you, everyone. Well, we'll just start with the excitement again here from the top. Welcome everyone to Two Alexes. My name is
Yeah.
Alex. My good friend over here.
Yeah. I'm also Alex. We are both Microsoft employees, but Microsoft would want nothing to do with this conversation. Um, so keep that in mind. And today we're going to talk about optimizing your Power BI models. It's going to be somewhat similar to the very first bit of the guy in the cube stream you may have just watched, but we're
That
going to
was
talk
awesome.
about it for the whole. Yeah, it was. We're going to talk for the whole hour, so hopefully we can get into a little bit more detail. Um, because that's what we strive to do on this show. So yeah,
We're gonna kind of dive into the trenches, and hopefully in today's stream, depending on where you're at in your journey, you're gonna see a little bit of yourself and maybe some of the past decisions that you made. I
hmm
am one of those people who loves getting my own work back after, like, I don't know, 6 or 12 months, because then I can look back and be like, oh gosh, what was I even thinking doing it that way? Hopefully that's where you kind of see the growth in your journey. So today, really, we've done all of these ourselves. We've corrected them
yep,
all. We're still making mistakes today, and hopefully we still get those opportunities to correct them, tomorrow and kind of into the future. So don't feel bad. If you see a little bit of yourself or your models and kind of the examples today, that is awesome. Finding
yeah,
and correcting those blind spots.
yep. So you want to get started, Alex, with the
Yeah,
date
yeah, I'm
table
gonna.
example or the date column example?
Yes, I would love to. And this is always kind of puts things in perspective.
Yeah, hold on, Alex. Hold on. Apparently, when I changed themes, it also muted you, so that's fun.
Oh,
Um, yeah.
then we'll
Let's
try
wait
this
until we
again.
get confirmation. And
I know all the wisdom Jessica's telling us.
yeah,
We're using OBS. Awesome. There we go. We're back. We'll just have to kind of keep that in mind on the scene switches.
yes.
So here, just single column. I want to show how one single innocent column can throw your entire model into turmoil. And I'm starting out with a blank query. Just there's no tricks up my sleeve. It's you're seeing me build it here now. So let's go ahead and start with just kind of a date. We'll do date time.
Oh man, you're just gonna go into the advanced editor and type?
Oh yeah. I mean, this is where I hang out.
Not me.
Why use the GUI?
I like buttons.
Oh man, no. So we'll do our start date here, and then we'll do list of dates equals dates, or let me do list dot date. Man, what is going on with IntelliSense? People are telling me it was
See,
not having a
this
good
is why you
time.
gotta use the buttons. Okay.
Oh, let's see here. There we go. List dot date time. So we'll start with our start dates. We'll do a count of 8 million, so 8,000,000,000. Our duration here is going to be so 0 days, 0 hours, and then 0 minutes and 1 second. So
Okay.
days, hours, minutes, seconds. And let's go ahead and create a table now. Table of dates equals table dot from list. We'll have our list here. So list of dates. Man, IntelliSense is just not having a good time today. List of dates. And I know why, Alex. I'm just not going to say it.
Yeah.
It's because I had to install the Power BI desktop manually.
Oh, that's
I'll
right.
do
We
splitter.
talked about that. I didn't end up doing that though. So
Ah,
I know.
why are you torturing me? Type table, and then we'll do our metadata here now, and this will be our date time as date time. Cool. Let me go up a line here. Get that taken care of. So we've got our table of dates. No syntax errors have been detected.
So this is a funny example because I had almost exactly this in one of my models. We have a table that has a list of accounts, and there's 7.5 million accounts, and it had a create date time field, and so there was 8 million date times down to the second in that column.
100%. So in our example here, we're incrementing 1 second at a time. So starting with 2000, just January 1st, the next second, the next second, the next second. So every row is completely unique, right?
Yeah.
So let's go ahead and save this one here then. So we'll do our just date time. Do a file save as. So we'll do close and apply to load this into our model. So every row is completely unique. Leluchar is already yelling at us here in the comments. He's saying, don't do it. Don't bring all that uniqueness into the Vertipack engine. I mean, it's 8 million rows. Like, that's not a lot of data, right? Like, I'm not really too worried about it. Power BI is out there demoing trillions and trillions of rows. 8 million is nothing. I'm not worried about it.
You know, my team this week was working on loading a 300 million unique value key to our model. It took some doing. We are solidly over the 10 gigabyte model size.
Nice. All right, so we've got 8 million rows loaded. So I feel good here. It loaded. It's fast. You know, we weren't waiting for hours and hours here on the stream.
Oh.
So this is just a single column. I've got to do my file save as here now. Then let's save this as our date time. So this is our date time example.
Yeah, you know, just because you can do something, one of your users will do it.
Yep.
That's the completion of that sentence.
I mean, in this example, like, I don't know, it doesn't feel that harmful, right?
Yeah,
like,
I mean, this column will come in automatically from lots of data sources this way.
Yep. So we're saving our file, and then I'll make a little bit of an edit here. We'll maybe try like splitting like our date and our time part out, just to, I don't know, maybe see if there's a difference at all. Cool. So let's jump back into our Power Query now. So we've got our date time example. We're going to do our splitter. I'm going to use the graphical user interface this time. Don't worry. We're not going to kind of jump into the code. So just a simple split here.
Hey, Alex, do you want to hit some zoom in again?
Yep. So do our add column, and then we'll just do a time. So we'll do a time only. So now we have our time kind of sectioned out here, and then we'll transform this column here to just do date only. Cool. And I'm a bit of a madman, so I'm going to actually go back to our list of dates. I know we said 8 million. Let's go ahead and kind of 10x that, if you don't mind. Let's do 10 times the amount of data. So we're going to have 80 million now. And let's go ahead and close and load this into our model. Close and apply.
Okay.
10 times the amount of data. I mean, this is just going to be massive, right? Like the model size is just purely going to bloat up in this example. What are you thinking, Alex?
I'm thinking that this version is going to be 50 times smaller.
Really? Man. What are you thinking in the chat? We've got two different models here. So I've got one with 8 million rows. And I've got another with 80 million. What are you thinking? Do you think that the single column, kind of that PBIX model, is that going to be smaller? Or do you think that because there's 80 million rows, that one's just, it's going to be way bigger? There's just no way that 80 million is going to be smaller than an 8 million. Awesome. So Paul is coming back. He's saying smaller. He thinks because of the better cardinality.
Yeah.
So cardinality here, Alex, what are we thinking here? Because I've got this time column.
Cardinality is a big fancy word, but what it means is the number of unique values. And because Power BI does a dictionary encode on just about every single column, cardinality is the most important number. And so anything you do to reduce cardinality is probably going to reduce the size of your model. There are points where you pay more for the model, and when we switch over to the next example, we'll talk about how you can see when this is happening. But the vast majority of the time, reducing the cardinality makes a huge difference in the size of the columns. And so...
Yep. And in this example, the time has a finite end, right?
Yeah.
Like 86,400.
Yeah.
Like, that's great.
So one of the ways that I think about this is I try to think about each fundamental granularity having its own column or its own table. And date and time, while they are related, a date and a time have no relation to each other. Any time can have any date, and any date can have any time. They do a full cross join. And so they are not fundamentally the same granularity and belong as far away from each other as possible. And this is why we always have a date table, is because date is not related to any other dimension. I'm going to turn up my volume here.
Yep.
Date is not related to any other dimension in your model. And so it almost always needs to go in its own table. And time is the same way. There's not going to be a correlation between time and... I mean, there might be some correlation, but a strong correlation between time and another dimension. And so it needs to be on its own.
Yeah, and if you are doing any type of like multi-day type of evaluation, so maybe it was like an order date versus a ship date, and those cross the span of two dates, compare the date portions, then compare the time. I mean, you can come up with kind of the aggregate value. So if let's say it was 7/11 and it didn't ship until 7/12, I mean that's a full 24 hours. You can do the math to kind of come up with that time portion, and then you just kind of using the iterator functions too. So if you are still needing to do some type of multi-day, you are fine. You do not have to keep those all in just one column.
Yeah. So we've got a good question here, and that comes in, which is, what do you do when your users are very picky with decimal numbers? And this is really close to home for me because I am a big fan of imprecision. I think that if you get within 1-2%, you probably is like from a decision making perspective, there is very little difference between being 1 or 2% apart. But sometimes you want to be correct to the 10th of a cent. How do you deal with that?
I mean, Power BI should, in theory, be summarized.
Yeah.
Like a summary of your data. It should not be the law of the land. Yeah. So if you've got somebody that's really nitpicking for the 15th, 16th decimal place precision, Power BI would probably not be the best tool for those examples.
I mean, you definitely do have floating precision data types. So in the query editor, you have 2 decimal data types. There's the currency data type, which has 4 decimal points, not 2, despite what you might think. And then you have the float, which has as many as you'd see normally. And so you definitely can choose the floating point decimals. The floating point, as Chris says, is much worse. Well, he's actually talking about the fact that Powers' query took so long, which is we'll come back to that in a second. But to finish off, like, the decimal type can be much worse if you have lots of decimals. If most of your data is only 2 to 4 decimal points, it's not going to be orders of magnitude worse. Most of the efficiency of changing the data encoding comes from reducing the cardinality, like we were talking about, not from making the numeric encoding format more efficient, though there is savings there. So here we've got our answer.
Whew. So left-hand side was our date time column, just a simple column, 82.7 megs. Each row was completely unique.
Yeah.
You had to take all that up into memory. Yeah. There was absolutely no compression.
Yeah.
On our right-hand side here, date and time, kind of time being our finite series, so there's only 86,400 possible kind of items within that kind of that dictionary. And then also our date, because it had to kind of repeat, was able to find those patterns. So 82.7 megabytes for 8 million rows. And then we 10x'd it, and we went up to 80 million rows. It only cost us 6.17 megabytes.
So I was a little off. I said 50. It's more like 15 times smaller.
Yeah.
But one of the things Chris Wagner said is like, oh, wow, it ran for such a long time. Shouldn't it be much worse? And the answer is sort of yes. Power Query is not compressed. And so when it's building the data structure before it goes into your data model, sort of normal data size rules apply. If you have more rows, if you have more columns, like each value takes up space on its own. And so the query took a lot longer, and this is why you might consider separating these into separate tables. It's because they're not related at all. And if we put them in separate tables, we would have 80 million date times, but there would only be, 1/24th, so like 4 million dates, and only there's a finite number of seconds, period. And so you'll never have more on the second side.
Then to call this out for Fernando again, just the left-hand side is the date time example, and then the right here is the date and time. So single column, and then kind of 2 columns kind of here on the right. So 8 million rows versus 80 million. Yeah. It's a stark difference. And then I'm going to come back to at least kind of talking about the overall time. And this is from a session that I did recently here. So welcome to kind of the complete process. The analysis services implementation within Power BI, it reads rows at 1 million at a time.
Yeah.
It then puts those into a compressed segment. So it's actually a little bit faster, whereas like typical SQL Server analysis services or Azure analysis services is 8 million rows. Yeah. So that's actually a little bit slower, but you get a better compression rate. And then kind of right here, it's in that final kind of that last blast into the data model. That's where it's taking all those compressed read segments from your get data process and then putting those into the actual data model. So the whole Verta package and compression segment. And then starting to build things then on top as well. So hierarchies, calculated columns, relationships, and then any changes that you may do. Whenever you kind of see that little spinning wheel within your model kind of up here in the top right, those little slow incremental changes are forcing your model to reprocess. Yeah. So definitely a lot of optimization things to think about there.
Yeah, and one of the things that about this is it's processing everything. So if you have calculated columns and you change the name of a measure that's unrelated to calculated columns, it'll recalculate those columns. Now, I think Casper was posting on Twitter the other day that he would like, and he thinks there's a great opportunity to make the repress engine be smart about using the dependency tree, but that's not on the roadmap yet. So we also, Alt-Inner wanted us to go back and talk a little bit more about the Power Query engine and how the load time was. So the Power Query engine is a bit different. It has a 250 megabyte container size, and so it'll only hold 250 megs of data before it has to page to disk. And in that data, it's not compressed at all because it's actually working with the data. And so it's going to take up the same amount of time, space as like a regular CSV or a SQL Server page, because it's in a traditional, table format so that it can apply all these transforms. So.
And I'm a huge fan of query folding.
Mm-hmm.
If you follow me kind of over on Twitter, just the 30-day challenge. But anytime where you can start feeling like Power Query is getting a little bit sluggish, like as you're clicking about and you're just noticing kind of the little yellow dots, just constantly cycling, you're just stuck and throttling in that mashup engine.
Mm-hmm. And
that's where, especially like on the reload times, I mean, those things are just going to bloat. So it's either, I mean, in a utopian state, Power Query would be a simple, straight read. Just read of the data, no transformations. If you're needing to do a lot of transformations, it's just like the cost benefit of, if I do all these on this side, I'm just accepting that my data kind of refresh times are going to be a little bit longer, as opposed to going further upstream. If you have an ETL job and just correcting those on that side, you're going to experience a lot more benefits kind of doing them further upstream.
In Power BI Premium, you can actually increase the container size if used, which helps a bit, but it's still like it's not going to take a multi-gigabyte memory grant to do a merge, and so you're going to see some paging to disk, which is not.
Yeah, I'm loving the comments here. People are trying fuzzy merge, and that just straight up killed some of their queries. That is a very memory intensive one, so. It's great for kind of proof of concepting, but if you're building anything more long-term, always go back and fix things upstream. You're just going to have a much better time.
Yeah.
But let's go ahead and kind of jump over to your screen here, Alex.
Let's take a look.
We'll start looking at a model.
Yeah, so let's see. Do we still have all our audio?
Let us know on the audio.
Yeah.
If you could confirm for us.
Okay, so this is a real model that was used. One of my coworkers shared with me, and we're going to take a look at this model and some things we can do to optimize. So yeah, here's the
Let's let the comments kind of rattle some things off. What are they seeing just right off the bat?
Yeah.
Before we say anything, what's everyone else seeing? I see Paul is he's seen all these bidirectionals.
Mm-hmm.
It's kind of giving him a nervous sweat.
Yeah, me too. So
we might have some snowflakes here too. I'm
gonna scroll down in some of these, and you're gonna see some more stuff that's going to jump out at you. Yeah, there's a couple many-to-many relationships in here, which isn't a super good idea, and I'll just try and highlight where our keys are. Okay, so we're seeing a lot about one-to-ones, many-to-manys. The model did not come to me organized like this, so someone posted dims on top, facts below. I did my best to organize the tables in that way for you, based on the relationships. So down here we have our tables that are only ever on the many side, but if we scroll here we can see these are fact columns. in what appears to be maybe a dimension table. Like, I think this is bridging over to here. Yeah.
It's a lot.
I actually love disconnected tables. And this sort of goes to show that the Power BI Literator is not wise. He just says lots of things, and sometimes he's right. As you would expect with any pro wrestler. Yeah. But so the dim on top, facts below comes from Rob Colley in the early Power Pivot days. But yeah, okay, so now that we've looked at this, I want to jump over to the model diagram that we looked at before, this is in our last stream we talked about this report that is, it's Vertipack Analyzer, but we've re-implemented the queries in Power BI. And one of the things that's nice about that is it's going to be a lot easier for us to read together without having to do too much zoom it, although we might have to do some. When we were back in the other view, one of the things that you may have noticed, so I'm going to start listing things that I noticed now, is we have all of these weekly revenue, I'm assuming, prior to last year. Like, this is a time intelligence measure implemented as a column, and it's 2% of our model, and 2% of our model, and 2% of, and it just, like, that is a pretty big cost. The other thing that really jumps out to me on this view is we have a lot of size in this table, and yet it does not, it's not the biggest table by rows. And our dictionary is much, much bigger than our data, which is good, but not super common. Usually, well, no, I take that back. It's not super good. This means that the unique values in the dictionary are driving it, and there's not a lot of repeats of those values. Because the dictionary is like the list of unique values for each column, and the data is the mapping of those data back to the column references. And I see this is closer to 50-50 more often. Alex, does anything else jump out at you? And let me know if you want me to go back to the relationship view.
No, I mean, I think the columns is a good call out, and you know, I'm very anti calculated column, but they do have a place. Like thinking about that split there of like pre-processing versus post-processing. If I had a massive fact table and I wanted to maybe create a calculated column that summarizes it against my dim table, so then that way it's just blazing fast for my end users, I might do that. As opposed to going through maybe like a billion row table or a trillion row. I'm just going to say, create this calculated column so at the time of processing, I've got this aggregate value. But anytime where I'm seeing things where it's like, you know, almost a repeated pattern, why is that not being done with DAX and just aggregations?
So Tenacious Data asks an important question, which is there any way to buy us coffee? And the answer is that we need 1,000 subscribers to turn on YouTube monetization. So promote the channel.
Yep, and then Jessica had asked a great question here. So the dictionary is not a table; it's more of a metadata feature. So when we talk about encoding, there's two types of encoding. So there's dictionary, and then there's value.
And also hash. But always what's happening.
So hash and value.
Yep. You're right. That's the dictionary encode. What is happening in there is you see, if you go to the Vertipack details page, which in other versions of Vertipack Analyzer is the only page, you'll see that you have the column size, the dictionary size, the data size. The column size is basically the sum of each of these. So when you load data, it automatically creates a dictionary, which is in hash encoding is basically a list of all your unique values. And then the column size, or the data part, is a key. It creates a unique key for each value and then builds a mapping table that says, this date matches up to this customer, matches up to this store. Like it builds a little star schema or fully normalized table out of every single column. It does that on the back end, which is part of why we don't ever see encouraging normalization in the databases. Yeah, so the dictionary is driven by the cardinality, and it's also driven by the encoding. So the data size is always going to be an integer, but the dictionary will depend on the data type. So here, one of the reasons this is so big, in addition to having double the cardinality, is it's a string. And so keys that are strings are another thing that should really jump out at you and say, why is that? There's two common reasons for this. One is that you're using some sort of GUID that's coming from your source. And two is you have a multi-part relationship and you created a composite key in Power Query. Because Power Query, because of the thing we were talking about before of merges, there's not an efficient way to create a surrogate key. Because effectively, to create a surrogate key, you have to join your tables around to make sure that you get the key everywhere. And so you really need to do that upstream. If you're trying to do that in Power Query, you're going to have a really bad time, which is really unfortunate.
Do you mind switch over to my screen here? I've just got a really good PowerPoint that I can kind of use here just to illustrate and kind of paint the mental photo here for everyone. So two different types of encoding. One is going to be value. Value of the cell itself is used. So in this example, let's use the fictitious number 10,000. Your values range from 10,000 to, let's say, 10,500. Instead of storing all of that, it's just going to remove the 10,000 as kind of that common element, and it'll just say values from 0 to 500. And then whenever it does kind of the actual aggregation portion, it's going to add that 10,000 back into it. So in that way, you can keep a lower size kind of those integer values. So that's value-based encoding. Hash is where it's going to actually create a dictionary for you. So kind of in this example, as we were showing here, and let me just go ahead and kind of pass on through here. And here are just the terrible fields kind of watch out for. High cardinality, so those date times, unique IDs, text, any free-form fields that I see in a report, I'm always a bit cautious on is what am I doing with that text analytics? If I'm trying to get a value out of it like a sentiment, I would much rather just get the sentiment score. So what is the actual like 0 through 1 that we're trying to accomplish? And then kind of here within the Vertipack engine, so kind of talking about that dictionary encoding. So our data dictionary and then our dictionary encoding. So here is just a simple table, right? Just a color red. So we got blue, green, green. So we've got a little bit of kind of repeat values here. So what it's going to do is it's going to create a dictionary now here for us. So it's going to say my dictionary ID for red is now labeled as 0. My pattern for blue is now 1. Green, wherever I see that, is now a 2. And then from there, it's going to also create that unique ID. So anywhere where that pattern is now found. So if I had multiple columns, just keep in mind if you were throwing out like a table or a matrix visual, it's now creating this dictionary on your page to say anywhere where that combination is found, I'm going to encode it with kind of this ID. So 0, 1, 2, 2, 3, 3, it's finding those patterns. Column encoding now, so it gets rid of that original kind of that color value. And then from here, it starts moving into evaluation.
Yeah, and it also does the same thing for that value column that you have. Although the value column, it may use value encoding, which there's a couple approaches. But often what it'll do is find a common denominator and basically make all the numbers as small as possible. And then, again, do a unique key on top of that.
And this is right here, like, I love looking at this. So it finds the first 0, it then scans and says, no, you're not 0. You're not. Oh, here we go. We found another pattern, moves on to 1. I mean, this looks terrible and this looks messy, right? This looks awful. Because everything that I know about the analysis services kind of databases is that it's blazing fast for aggregation. And this is where optimal sort order comes in. So it now starts creating, kind of within that pattern, the run length encoding.
Yeah.
So we'll optimally sort your data. Say red now starts at 1 and goes for a count of 3. So 1, 2, 3 doesn't look at anything more or anything less.
Yeah.
And now if we were to look at this evaluation process, so that blazing fast experience of Power BI, this is what it looks like underneath the hood.
Yeah. And with more columns, you might just end up having literally fewer rows. If you don't have any column that's purely unique, the thing it stores will actually have less rows than the thing it started with. It's fantastic. So.
Yeah. Well, take it back to your screen.
Yeah.
I love just talking about.
Yeah. Okay, so I want to go back to the model view here, and I want to talk about a couple more things that jumped out at me. And this is going to continue the theme of keys. So we saw that this key is super big, and also it doesn't participate in any relationships. So 8% of our model is in a key column that we're not using. Okay, so that's a thing that we should look at. It's possible that this is being used in visuals, and we're not going to look at the visuals because that is confidential data. But based on the name, we can assume that maybe we don't need that column at all. And if we come into Tabular Editor and look at the key column, this is coming in from our source. So this is not a DAX column, which would make it especially troublesome. The other thing I noticed is this bridge table really sticks out to me, and I'll tell you why. One is I have some domain knowledge and know that there's a one that it's bridging accounts to customers, and I know that in our business, accounts can only have one customer, and they'll never have more things. So that tells me that this bridge table is not necessary. And also what I see is I have customer ID, account ID here. In this table, I have customer ID, account ID here. I have account ID, I have customer ID. And so I don't need this bridge table at all. I can just use directly relate to customer ID in this fact table. Since I'm already using a many-to-many relationship, I might as well have that many-to-many relationship be to the actual dimension and not through a bridge table. And also, so that's something that jumped out to me. And then the other thing, some folks pointed out one-to-one relationships, which is a really good point, which sort of comes back to what I was pointing out about we already have the key values in these tables that are related to this bridge, which is to say these are the same table. I don't need this table to do anything. I could just relate all of these directly to this table instead and have it pass its filters on. And then here, where these are the same thing, I can combine these into one table. Sometimes separating things into tables makes it easier for users to understand, but here we only have 5 columns that we're going to show, maybe 6, and they're definitely related. So having them be separate isn't super necessary. Yeah, weeding the garden is a good analogy. The other thing is that our relationships do have costs. And I'm going to come over here to this relationship by size. And what we're going to see is that we pay a data size cost for relationships. And if you look at the pattern here, you'll see that our bidirectional relationships Generally bidirectional. Like if I were to take, and I'm not going to do this because I don't quite have it set up to refresh fast enough. But if you take a relationship and change it from a single directional to a bidirectional, the relationship is almost going to double in its data cost. And so while these numbers are relatively small compared to the size of your model, they're going to save size by combining these tables. It doesn't matter if it's adding more rows or more columns because, again, we're going to get that per column encoding. So it doesn't really matter where the data is as long as the cardinality is controlled. And the other thing is that bidirectional relationships are slow. And I don't think we're set up to do demos on that today. But yeah. 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 Yeah, yeah. Oh, did we do that again?
Blue store. There we go. Pearls of wisdom lost. Let us know if we're back. Yay, there we go. Man, I don't know. We fixed the video. Next time audio, I guess. So kind of talking about over on Twitter, me and Alex were having a nice little discussion just about true and false values versus replacing those with like a yes, no. So this to me is like it's a fun discussion, and the reason why I enjoy it is because true and false is going to be stored as just an integer value, underneath the hood, whereas a yes, no is going to be stored as a string. Strings are always more expensive than an integer, and in my example, I was like, well, if I gave you a 7 billion row table of only 2 values, so of only true, false, or yes, no, we're still going to have extremely great compression because the cardinality, right?
Yeah.
But it's these small things of like, if you let one small thing slide, then what is the next thing you let slide? Then the next thing. And in my example of a true, false versus a yes, no, it was bytes. Yeah. It wasn't gigabytes. It wasn't, even kilobytes. I'm talking bytes.
Right.
Extremely small things.
Yeah.
So and that's where I always give pause. I'm always like, if I let the small thing slide, what will I eventually kind of slip and let something else much larger slide?
Yeah. So when you're optimizing model, I definitely think that you need to think about what you're optimizing for and how to spend your time effectively. When you're designing the model, you definitely want to try to internalize these best practices so that you don't make these mistakes, because when you're optimizing, you're going to have to just take off the highest priority things. So we've actually got a really good example here. So when you think about optimizing, like, what are we trying to accomplish? I think there's really 3 possible goals that we can have. We might have all of them. One is make the model less than 1 gigabyte so it will fit into Pro. The second is make queries run faster. The third is make refreshes faster. And the fourth is I've got premium capacity and I need to reduce my memory footprint in general. And I don't really care where the memory cuts come from. And so you may be trying to make 1 gigabyte models or 800 meg models smaller, and you may also be trying to, like, in general, though, if you're not on premium capacity, I don't think you really gain much purely from making the model smaller. It has to accomplish one of those other goals. But here's the case. This model, it's 2 gigs in memory. It's 800 megs on disk. And the owner of the model reached out to me and was like, hey, we're not done adding data to this model. We we think we're going to need to go on premium capacity. And Microsoft has pro licenses for everybody. So and there's no way to get a refund for those. So when you decide to go on premium, it's a very expensive decision. And so we talked about that key that was really causing us some problems. The other thing that this is where it's a small deal, but it starts to become a big deal really fast if you implement it across lots of models, or you repeat if it becomes a pattern. Here we've got this column, and I'm going to pull up this column in Tabular Editor, and we'll take a look at what's going on there. So this is the weekly rev table. Taxonomy is next. Here. Okay. So we'll start with prior to last year. And I'm going to format this DAX here. Okay, so what we've done is we're calculating a measure, and we're applying a time intelligence pattern. And then we're doing the same thing with a different time intelligence modifier. And the same. Okay. So if it was just making your model 2% bigger, I don't really care. But here, it's not making your model 2% bigger. It's making your model 30% bigger. And so that's where allowing bad practice to slip in can really start to cost you. And this could have cost us, a couple $1,000s a month if they had, decided the solution to this was buy premium. Because this should actually be a time intelligence matter, right?
Yeah, I mean, if Power BI is not your 40-hour-a-week job, I don't want you to spend 200 hours to possibly shave off 3% of your model size.
Right.
That may not be worth it. So in some of these examples, it's cutting them off ahead of time. So building a proper, maybe it's a data flow of a calendar table that has a lot of these things. If you have some type of DAX pattern guide that you already have existing internally, those are great too. Man, there's just so many.
Yeah.
Because we've all built this model. I built it, you built it. It's as we go, the little things we're picking up along the way, and especially for me, kind of thinking about the relationship size. I go through my mental checklist when I land on a kind of a report. So I don't care about any context of what is the business thing that I'm trying to solve. I'm just looking at it as a non-objective.
Yeah.
If I see Snowflake tables that only have 2 columns one is an ID and one is a value, I would ask myself, why is this needed? Because more than likely, in your top left here, maybe 2, 3, 4 columns in some of these examples, all of that is getting taken up into memory. I already know that without even looking at the data, because all that is in my mind is probably just a unique value.
Yeah.
So actually doing the merge, doing a join over on the Power Query side, you're actually going to get a lower model size by bringing your tables together in some of these examples.
Yeah.
That's not always the case, though. If you're trying to, bring in a 5-row table into, let's say, a 20 million or 50 million row table, you may not see kind of the benefit of doing a merge.
Yeah. And you always have to keep in mind with doing mergers in Power Query that if it's not folding across, you're paying a really big cost for that.
Yep.
And so, again, this is where some of the trade-offs of optimization come in. If you're not going to gain anything in model performance, and you're just the differences between a 100 meg and a 300 meg model, it's probably better to save the refresh time.
Oh, man.
Yeah.
Back-end experiences versus front-end, right? I don't, if it takes a little bit longer on the back end for something to refresh and process, that is going to be great because then I'm not getting an email from my end user saying, this is slow, this is too complex, I can't use it.
Yeah.
Those are all the front end interactions. We want to make those the best experience possible, right?
But it's important not to forget that if your queries are slow, that means when you have a bug, you're going to spend way more time trying to figure out what the problem is and fixing it. And then once you have a solution, trying to implement those changes, right? And so if you start getting into that hour, 90-minute refresh time, which I have lots of experience with, like you're not going to want to add features or solve user problems because you're going to spend all day waiting on queries to refresh, and you may or may not find the problem.
Yeah. I mean, like I said, as someone who has worked in a full-time kind of Power BI developer role, like I've taken 250 megabyte files down to 20 megabytes.
Yeah.
Like all of these things are extremely possible. You just have to follow kind of the mental checklist of going through, fixing things. Kind of correcting a lot of these cardinality issues, but if it's not your full-time job, kind of weigh the cost benefit.
Yeah, so we can sort of start to do that exercise here because we started to talk about okay, so we identified that this key is probably not native. So we're taking 8% off our model here.
That's insane. That is huge.
We've just identified that this probably isn't needed. We haven't looked at these columns, but revenue fraction, these also look like measures to me. And so we might be able to save another 10% here. We talked about these measures, and so that's like, we're talking about taking these measures down from 800 megs down to, I don't know, less than 100. Just with the stuff we've talked about today. And there's more opportunities in here that we haven't really gotten into. And that's going to make a big difference in your user experience as well. Now, we haven't really looked at measure optimization because to really do that, we need to look at the data. And we wanted to keep this, we wanted to do real world examples, so we planned this around things you can do without ever looking at the actual data in the model.
Because if you got like the VPAX file, right?
Yeah.
Like a lot of these, you could just read the columns. You could just read kind of the the cardinality, the dictionary sizes, and you can make a pretty best guess. It's wild.
Yeah. So let's go to a couple. I see a couple good questions. So I'm gonna start with Alt Enter's question here about, for the columns you think you could convert to the measure, are these the kind of things you talk to the end user or data owner about first? So the report owner needs to know if you change a column into a measure, any visuals that reference that column or any subsequent calculations that reference that column are going to break and need to be remapped. If your end users are using Live Connect to your model using shared data sets, similarly, like those changes are going to cause them problems. So, like, yeah, you can't just, like, if you manage a premium capacity, you can't just, like, go in and edit people's models for them and have everybody be happy. So, let's see. Another question. We have a question about query folding. So, Alex, I think you should take this question.
Yeah. So let's go and take a look here from Jessica. So I have a question about query folding. Doesn't that mean that you have permissions to write back or alter the source data? Not at all. So Power Query is a read-only tool.
Yeah.
So it does not affect any of the underlying data. Query folding is, the best description I can always give is, let's say we have a SQL server with 256 gigabytes of just raw memory. It's just incredible. It's all the heavy lifting. Or we have the mashup engine, and as we kind of talked about, kind of that 250 megabyte container. If I'm looking at where do I want to spend most of my time, do I want to have the heavy lifting done on my server, that 256 gigabytes, or do I just want to kind of use my little 250 megabytes?
Yeah.
I want to keep everything server side. So that is what query folding does, is it allows all the heavy lifting to be done on the source system. So whether that be kind of a database, some OData feeds may also support a lot of things that probably won't, web API. More than likely that's not going to be exposed with the database. So things like that, whenever you start feeling that slow crawl, you're in the mashup engine.
Yeah.
So
Power Query was originally designed not as a data transformation tool, but as a meta query translation engine. Like, what does that mean? It means that you can write a query in M, and Power Query tries to translate that query into all the languages that it speaks. So if it can, it'll rewrite a SQL statement that encapsulates the whole query. And if it can't, it'll say, okay, I'll translate as much as I can to this source and then do what I can't translate myself. And so its primary function is to try and push things up. And there's lots of sources where it can't know what the language is. So for REST APIs, like the Power BI team is not going out and reading everybody's API documentation so it can know how to fold your filters into their API syntax. Now, if it's a standard open format like SQL, like OData, then they can do that. But if it's just like, well, hey, the Spotify API has this filter clause and like this group by clause, like they're not going to figure that out for you. Similarly, it's not, if you write your own SQL, it's not going to presume to rewrite your SQL, which seems reasonable, but trips a lot of folks up. So yeah, that's sort of what's going on in the back end.
Man, some really great questions here coming up, at least on the kind of the back end and kind of optimizations here. So Mark said we were changing to REST API for our data sources. Will this change query performance in PQ? Good chance. Yeah. It really depends on what you're going after on that REST API. I'll go ahead and share a resource from kind of Gilbert over at Formu. He did a really awesome incremental refresh series here lately where he got any data source to fold and kind of do the incremental.
Yeah.
So if your REST API call is to, like, let's say previous day's results and those don't change, man, you could have a really good time. If you're saying, well, dates 7 days ago could be changing on that REST API, there's a very good chance you're not going to have a very fun experience.
Yeah. So for Data Lake, there's not a fully featured folding. However, if your data is clearly partitioned, it may, I wouldn't count on this, but it may know only to download the partitions for this year if you filter to this year. But that doesn't always work for you. Query outsourcing is a great way to think about it. The other question, because we only have 2 minutes left, is I want to go back to one of Chris Wagner's comments, which is he was talking about, he said, I'm warming up on Tabular Editor for team development. Saw a demo of how it can effectively be used across a large team. Looks like it needs more Git integration. And we have a session that we have been keeping in our back pocket for a while now on exactly this topic, using Tabular Editor in how it affects dev processes. And we've been waiting for external tools to launch publicly to do the session, because I think it really changes the workflow. And so I suspect that our next session in 2 weeks is going to be about that. Unless something changes with the plans for Power BI desktop releases. Will has said that we should expect it on the second Monday of the month, which is this coming Monday. And so, yeah, unless something changes, we're probably going to be talking about that in our next show.
Yeah. I think the Power BI luchador has got you here on the hint.
Yeah.
Don't rewatch this video and look and concentrate at the very top left of the navigation pane there. Don't do that. I'm just giving you that warning. Don't look up there. But no, I think the game is going to be changed too whenever external tools kind of get released. There are so many exciting things that are going to be done for developers. And the biggest thing for me is I think that community contributions around DAX measures, it's going to be wild. So if you think about DAX patterns, if you've ever used that to just like copy and paste and kind of change your field names, I think that's going to be something to watch out for kind of here throughout 2020.
And most of the stuff that I think is good was already sort of possible with XMLA, right? But or even just by like using TBITs intelligently. But one of the important things with source control, even if we don't have like full source support, is you need to have a like continuous flow of your artifact. If you're like saving in one format and then saving in another format and merging and then saving to a third format, like you're not actually going to do that consistently. And external tools is going to enable us to do work, save it, and deploy it, and not like do a big circular thing to get all the formats to line up.
Yeah. Well, let's wrap up here. I know we're at the top of the hour. So we'll see everyone kind of here again in 2 weeks. We'll continue to kind of work on some of the technical issues, but appreciate everyone always for hanging out and kind of calling those out for us and getting us back on track here. Hopefully I'm not on mute. Maybe they'll yell at us now if the scene muted us. For me though, learn about the little small things. Like, how does a date time column respond? How does even have true, false, illogical? How does a string, just free form text? The more you can just look at columns, just not within a context of like the business problem, but the actual technology. And then whenever you get back to the business, you're like, all right, I know the technology. How do I meld this with the business? That's when you can really start making these really great design decisions.
So thanks everybody, and we will see you in 2 weeks.